Okay, all right. So if you go to the top of your screen, as mine is, the top part is talking about what is called intervals of increase and decrease. And so that's the vocabulary you had just described to me, if something's increasing or decreasing. The bottom of the screen is talking about a completely different concept, and that's talking about positive and negative Y values. So that's why I was thinking you might be confused as putting these all into one lesson. So they're two different things. So for the top part, which would be the first so many questions, I'm assuming, I'm not sure what kind of order you're getting the questions in, but if it uses the word increasing or decreasing, then we're talking about these pictures up here. So for this picture right here, there we go. If you look at, this is a totally different graph than what we're used to, but the purpose of it is to show you what lines and curves look like as far as increasing and decreasing. But this left side of this graph here is increasing because it looks like a positive slope. As well as this piece over here of this graph, we call that increasing because it also looks like it has a positive slope. And then this piece of the same graph is decreasing because it looks like it has a negative slope. Now, the reason we call these increasing and decreasing is defined right below it. It says a function is increasing over a certain interval, which is a starting and stopping number, if the function increases, the x values increase as the y values increase. So, for example, over here, as my x values are getting larger because they're heading away from the negative numbers, the y values, although they're down here at the beginning, I start to have to go up to get them. So they are increasing. The values of them are getting larger. Over here, as my x values are increasing, I'm going down, but then I start going up to get to them. The y values increase as the x values increase. Now, as far as decreasing is concerned, it is a function is decreasing on an interval, and I'm getting this from right here at the bottom, this definition, and an interval means a starting and stopping number. If the values decrease as my x values increase. So if you look over here, I'm still increasing on my x-axis, meaning I'm heading away from those negative numbers and going towards the positive. So my x values are increasing as I move to the right. But starting right here, I'm going up to get those y values, but I slowly start going down, and then I'm going down, and I'm going down because those y values are decreasing. So this has an opposite relationship. As x values increase, the y values are decreasing. And that's the gist of what increasing and decreasing is all about. Now, it doesn't have anything to do with positive and negative intervals. I was using positive and negative slopes so that you can visually see what it looks like. If you go over here to these inverse variation functions, I'm going to show you these two examples, and these two pictures are going in the opposite directions. This is the parent function, and if you look on your graph, you could probably see it a little bit better, but the graph is purple right there, and it is in quadrant 1, and the other branch of this hyperbola graph is in quadrant 3. And a reflection is taking place over here in the second graph, where the branches are in quadrant 2 and quadrant 4. Now, as far as increasing and decreasing, the same definitions apply. The graphs look different though. So for these graphs, it's a little bit easier because all you have to do if you want to determine whether you're increasing or decreasing, excuse me, is take a straight edge right at the curve, tangent to the curve, and then look and see what kind of slope that looks like. What kind of slope does that look like?
Decreasing.
Right. And if you do the same thing to the other one, what does that look like?
Increasing.
Increasing. So just as a visual, you can just look at the graph and see whether the graph is increasing and decreasing, and it's going to be one or the other. This entire graph on both of its branches are decreasing, and this one, both of its branches are increasing. So it's either one answer or the other answer. Does that make sense so far?
Yes.
Okay, and then what are the intervals that they are increasing or decreasing? Well, if you go back a couple assignments, we talked about identifying the domain and the range of your inverse variation functions here. And what we learned is that the domain and the range are literally all real numbers, which means any number you can think of, except for the one number that represents the asymptote. And if you remember what asymptote means, it means that invisible fence that your graph doesn't cross. It's the invisible fence that divides the two branches. And in this first example here, that y-axis right there, which is called x equals 0, is the equation that represents the y-axis. This y-axis divides the left and the right branch. It looks like it's touching the y-axis, but it's not. And then the horizontal axis here, which the equation for that is y equals 0 because it crosses 0 on the y-axis there, is the horizontal asymptote. So once again, that is the horizontal line that your branches look like they are touching, but they're not. So I'm just going to make this a little bit easier to distinguish here. This is what it looked like, and I'm making them green. So what's happening is your branch over here is getting closer and closer to this 0 for the x value, x-axis here, but it's not going to touch there. So that means x will never be a part, 0 will never be a part of the domain because x represents your domain. So on the x-axis, this number 0 right here, this graph on the right, the branch on the right and the branch on the left aren't going to touch. So that's the only number that's not a part of your domain. So as far as intervals of increasing and decreasing are concerned, this entire branch here and this entire branch here is decreasing over the entire domain of the entire function. And the domain includes every single x value except for that vertical asymptote right there. Does that make sense so far?
Yes.
So what you need to do is make sure you know how to do domain and range, of course. And this is one way of writing that interval from negative infinity to that 0 asymptote. And then that's one branch, and then that's this branch. And then the other branch starts back up over the other side of the asymptote of 0 to infinity. Or it could be written as all values of x in the whole entire universe that are less than 0, that are greater than 0, but don't actually include the 0. And another way of saying it is all values of x except for the number 0. For this graph over here on the right, we already decided that it is increasing. And then once again, you just need to find its asymptotes, and it happens to be the exact same. There you go. X and Y intercepts right there. So this has the exact same domain because this asymptote right here tells you the one value of X that's not a part of your domain. Alrighty. So that's how intervals of increase and decrease work. You figure out which one it is, and then you identify the domain based on the asymptotes, and you're good to go. That make sense?
Yes.
Alrighty. The bottom part of this, which is half the questions, that talks about positive and negative intervals. And if you look at this picture right here at the bottom, you'll see it's marked off for you. Any point that is above the x-axis is going to have a positive y value, and any point located below the x-axis is going to have a negative y value. So the question is, what are the values of x? Right here it is, a good definition. What are the values of x that will produce positive y values? All of these points right here have positive y values. All of them are x and y values, and the y values are all positive. Okay? And then what values of x will produce negative y values? Well, all of these points here, no matter what the x is, the y is going to be negative. Same thing with this entire branch over here on the right. No matter what the x value is for each individual point that makes up that branch, every single one of the y values are negative. Does that make sense? Okay, so then you're asked to find what are the x values that will give you these negative y values or those positive y values. So you can see right here where the graph ends, which it doesn't end, all the way from negative infinity over there on the left, all the way up to that point right there on the x-axis. And that point is at a -1, I think. No, there it is. It's at a -1.75. That's at a -1.75 right there. That x-intercept is a -1.75, 0. That's the x-intercept. That's where the difference between positive and negative y values take place. So from negative infinity on the left all the way up to that x-intercept right there at the -1.75. All of these x values are going to pair up with negative y values. Does that make sense? Good. And then over here on the left side, on this branch, this asymptote is right here on the -1, okay? So on the other side of the asymptote is the second branch. Excuse me for a second. I'll be right back. Here, buddy. Hey, 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 hey. Come here. I know, you're okay. It's okay. Okay, so as I was saying, this second branch over here, these x values that go with these points start on the other side of that asymptote, and that asymptote is at -1. So starting at -1, but not including -1, that's why I have a parenthesis right here, because -1, the asymptote is not a part of the domain, all the way to the end, which it doesn't end at positive infinity for the x values, make up the negative interval. And then since you have two answers here, you have this piece on the left and you have this piece on the right, you use that little u. And that's what this is right here. That's what that answer is right there. Let me erase some of this. Now, for the positive interval, that's starting at the x-intercept, and then it stops at the asymptote. So once again, if you look really closely, you might have to zoom in on your picture a little bit. The asymptote is right here at -1. I guess you can see it better on your screen. That is the asymptote. That's the one value of x that divides the left and the right branch there vertically. Okay, that makes sense so far?
Mm-hmm.
So the piece of this graph that we had described to be positive y values right there, and it goes on forever and ever and ever, right there. It starts also at the x-intercept right there. But the y values that make up the x values that make up this pink part here just go from that x-intercept to the asymptote. So it's only this little sliver of x values. So starting at the x-intercept and ending at the asymptote, those x values in between those two numbers will pair up with positive y values to produce this graph right there. Okay? All right, so that's the entire lesson in a nutshell. So absorb that for a moment and ask me questions. What do you think? Do you have any questions?
No, you answered all of mine while you was going through the lesson.
Huh? What'd you say?
You answered all my.
Okay.
Answered all my questions.
All right, why don't you give it a try and then come back on? I'll be here till 12.
Okay.